Today we're going to be talking about some applications of differential equations. Our first example has, for a particular chemical reaction, the rate at which reactants change is proportional to the amount present. So the rate that the reactants change is proportional to the amount present. We have 90 grams. At t equals 0, we need to know after 4 hours. So honestly, there's a little bit of calculus to this, but a lot of it is actually pre-calculus. So we have our differential equation. And separate our variables out. Remember, on the AP, you need to separate your variables or they are not going to give you full credit. dt. We integrate both sides, so we get the ln of y is equal to negative 0.71 t plus c. Don't forget your plus c. You need to add in that plus c right when you take the integral. And on the EP, they're not going to give you credit. I think you get 3 out of 6 points. You lose 3 points for not adding in that plus c. Since y is positive, 90 grams at t equals 0, we can write this as an exponential. We don't have to worry about these absolute value signs. So e to the negative 0.71 t plus c is equal to y. Now that plus c, it's a little deceiving how I wrote it. That plus c is actually still part of our exponent. Now remember, this is some new constant. When you're adding exponents, that's really like saying e to this piece times e to the c. So we can really write that now as some other constant, big C, like that. Now this is just pre-calculus. Plug in 90 grams, which is your y, and plug in t equals 0. Anything to the 0 power goes to 1, so c ends up equaling 90. So we have our equation. And then now all you have to do is plug in this 4 for t. And in my calculator, we get 5.258 grams. And remember that you need to be correct to 3 decimal places. Now this other one is a little bit more complicated and gets to be a little bit some interesting math happening, but honestly a lot of it, there's just a little bit of calculus and then a lot of pre-calculus to it. And there's a whole bunch of steps to this. So let's break down this question. The rate of change of the number of foxes, n of t, in a population is directly proportional to this expression, where t is time in years. When t equals 0, our population is 250. And when t equals 3, the population increases to 500. And we need to find our population when t equals 5. Okay, so there's a lot of math going on here. In blue, I've highlighted the initial equation we have to come up with. So the rate of change of number of foxes is directly proportional to this expression. So dn dt is directly proportional to this expression. Where t is time in years. Okay, we need to solve this differential equation. So let's go through and separate our variables. And then I want you to go through and I want you to integrate. The right side is easy. Don't forget your plus c. The left side has a u substitution where u equals 550 minus n of t. So du is equal to a negative dn. So I need a negative outside and a negative. So then you have a u substitution of 1 over u du. So we get negative ln of our u Okay, when you plug in 250 here, that expression is inherently going to be positive, so we don't really need those absolute value signs. Okay, let's multiply everything by a negative before we convert it to an exponential. I often debate if I need to multiply and make that negative. I'm just going to leave it as a plus c, and it works out for us. So writing this is e to the negative kt. Remember, this big C as the exponent becomes a constant out front, is equal to 550 minus n of t. So solving for n of t, I'm going to subtract this term to the other side and add the n of t to the left. So n of t equals 550 minus c e to the negative kt. Now what I recommend you do, plug in t equals 0 and 250. So 250 is equal to 550 minus c e to the negative k times 0. Remember, that goes to 1. Solving for c, we get, let me find it on my paper, 300. Yes, I had to look for that on my paper. Make fun of me all you want. This goes to 1. I'm sorry, that goes to 1, so that's how we solve for c. Okay, sorry. So now we have our equation. N of t is equal to 550 minus c, which we just solved for. I apologize. 300 e to the negative kt. Our next job is to solve for k. We're given t equals 3 and 500. So 500 is equal to 550 minus 300 e to the negative k, and that was at 3. So isolating this e to the negative kt, we have e to the negative 3k is equal to 1/6. So now we do the ln of 1/6 is equal to negative 3k. K is equal to 0.597, correct to 3 decimal places. So now, let me extend our page. We have our big equation. Honestly, the only calculus we did was to here. Now this is all algebra. Okay, now I have my equation. N of t is equal to 550 minus 300 e to the negative 0.597 t. Now all I need to find is when t equals 5, so I plug in 5. And again, solving that in my calculator, we get 534.857. A lot of times the AP is going to say round to the nearest whole number. So 535 foxes. And that's how you'd solve that type of a problem. Honestly, on the AP, they're going to probably give you this differential equation. Sometimes I've seen a question similar to this on multiple choice. That's why I wanted to make sure I went through this. Please make sure your lesson summary below this video is submitted on time.